Hello, AP Calculus students of the future. Mr. Ford again with another summer packet tutorial. Today we're talking about topic J, negative and fractional. I don't like the word fractional. I prefer the word rational. Rational is a word that you use in high school math to describe anything that's got a fraction in it. The root word is the word ratio, which means you got something to something comparison. So we had a lot of rational functions in the last topic. These are all rational equations because they are fractions. Today we're dealing with rational exponents. So let's take a minute to review a couple of key ideas before we jump into a bunch of examples. Specifically today we're talking about negative and fractional, rational exponents, but we should also review some basic exponent rules too. These are things you start learning in your 8th grade and Algebra 1 days, and they just keep showing up. So first of all, if you got a to the n times it's got to be a to the n times a to the m. Usually n and m are used. This is n plus m. You can add those together. Not to be confused with a to the n raised to the m power, in which case you can multiply n times m together. And of course, if that works, then a to the n divided by a to the m is a to the n minus m, like this. And if you have, let's say, a to the n over a to the m all raised to the, x power, this would be a to the nx over a to the mx. The exponent just kind of applies to everything there. These are some basic rules, but we haven't talked about the big ones today. Let's talk about negative exponents first of all. This is one that takes students a lot of time to handle, and it takes a little practice. Once you get it, it's really simple. We can talk about why it works too. A to the negative nth power is the same as 1 over a to the nth power. And I think what's important to note is that 1 over a to the negative nth is also equal to a to the positive nth. In short, what you're going to do here is you're going to take that negative exponent, and if it's on the top of a fraction, you're going to move it to the bottom where it becomes positive. If it's already on the bottom, you move it to the top where it becomes positive. Keep in mind, a to the negative nth is technically over 1, and also over 1 right there too. So there's a bit of a flip that happens here too. Another case that you see a lot of times is you'll already have a fraction like a over b to the negative nth power, in which case what you do is flip the entire fraction and then raise everything to the nth power. B to the nth over a to the nth would be what's going on there. We could spend a lot of time talking about why this works, but I think that's outside of the scope of this particular video. I just want to give you a crash course and work through some examples. We'll have a lot of time to talk about and why negative exponents do that later on in the actual course. We also have your rational exponents, which I want you to connect with the idea of roots. That's really the key idea here. If you have a to the 1/2 power, for example, this is the square root of a. The same thing is true about a to the 1/3 power. This is the cube root of a. And basically, a to the 1 over nth power is just the nth root of a. Again, we could explain why that is, but it's outside of the scope of this particular video. Maybe at the end of the video, I'll come back over here and explain a little bit why that's the case. But for now, that's a good enough explanation. The only other thing I can add to this, let's say you had a to the, m over nth power. Something like this, where you had a fraction with a thing on top and a thing on bottom. Well, the top of that fraction is kind of the power that you're going to raise it to. And the bottom of that fraction is going to be the root that you're going to take. You can write this basically two different ways, and a lot of textbooks will basically have you do this exercise a lot of times when you learn this. This could be the nth root of a to the m power, like that, or you could write it as the nth root of a all raised to the mth power. These are both equivalent statements. They mean the same thing. A good explanation as to why that works is because you can easily split this up. You can say this, okay, this is a to the 1 over n raised to the m power. Or you could say, oh, that's a to the m raised to the 1 over n, making actually kind of a callback to this rule over here, the multiplication rule. Kind of making a callback there to this right there. That's the idea. Okay, with that in mind, again, you can pause this video right now and take a look and take some notes if you need to on this, but let's go ahead and jump into the examples. Number 1, 12 to the second, negative 12 to the second over times x to the negative 5th power. Our job here is to simplify everything and write it with positive exponents, so we're going to get rid of all of the negative exponents. So let's start with negative 12 squared. What's interesting here is that the negative sign is going to be outside of the 12 squared. So 12 to the second power is 144. But the way I'm reading this notation is that the negative sign is going to be applied after. So what we're going to have on the top here is negative 144. Consider the difference for a minute between negative 12 squared and negative 12 squared. The first one is negative 144. The second one is positive 144. It's all about what order you're going to go in. Are you squaring 12 or are you squaring negative 12? The top one I would read as negative 12 squared versus the second one, which is negative 12 squared. It's all about how you say it and where you put those parentheses and where your priority is. The calculator is a dangerous tool to be using here because a lot of Algebra 1 students and AP Calculus students run into the issue of typing the thing on the top in when they really mean the thing on the bottom. Anyway, I don't mean to get too long-winded about this easy example. Let's go ahead and move x to the fifth to the bottom of the fraction, and that's the answer we're looking for right there. I don't mean to get too long-winded. Okay, let's roll the next one. Here we go. This is what we're talking about. This is negative 12x to the fifth, and it's all being raised to the negative second power. The way I'm going to write this right away is move it all to the bottom of the fraction and change that to a positive second power. That is the key to understanding this. And now we can apply kind of the raising a power to a power rule. We're going to raise negative 12 and x to the fifth to the second power. If I'm breaking this all down and explaining everything, this is negative 12 to the fifth times x to the fifth, or sorry, negative 12 squared, my fault. It's negative 12 to the second times x to the fifth to the second. That power kind of distributes the way you would use a distributive property. So this is 1 over, well, positive 144 x to the 10th. That's what we're looking for there. Let's try another one here. Again, you want to kind of work through it piece by piece. Let's first take the outside negative first power, move to the bottom of the fraction, 4x to the negative first power to the first power. We can actually kind of ignore that first power. It doesn't really do anything here. The only thing I would do now is take x to the negative first power and move it back to the top of the fraction. This will be x over 4. Getting used to these equivalent forms for expressions is a big deal. A lot of times in calculus we run into problems that require us to think about it a different way or reframe the problem, and that unlocks your understanding of it. Let's try number 4. I'm going to slide over this way. Oh, here we have the fraction raised to a negative power. So the first thing we're going to do is flip that fraction, x to the fourth over negative 4, and this time we'll raise it to the positive third power. We change from negative 3 to positive 3 and flip the fraction. Of course, now we have to apply the third power to the top and the bottom. So this is x to the fourth to the third over negative 4 to the third. On top, that's x to the 12th power. Again, if we had more time in this video, I would write out x to the fourth times x to the fourth times x to the fourth and have you count up how many x's there are. That's what we do in Algebra 1. But for now, maybe just the shortcut. 4 times 3 is 12. On the bottom, that is going to be a negative number because it's an odd exponent. So negative 4 times negative 4 times negative 4 is a negative number. It's negative 64. I don't know if you know that in your head. You may or may not need a calculator for that. You can see I have my calculator right here. See, it's down there. Now it's up here. The magic of technology, but it doesn't matter. Okay, number 5. Again, this is very much similar to the last problem. We're going to start by flipping that fraction. We'll put y to the second power up there, 5x to the third down there. We'll change it to a positive third power, like that. And now we will apply it. You can skip a lot of these steps. I'm just making sure to explain everything because that's kind of my job, is the explainer. My job is to help you interpret a lot of the problems that you're going to be facing this year, and help you interpret is not the same thing as showing you the answer, but a lot of times that's what I do. So 5 to the third power is 125, and x to the third is x to the 9th. There you go. It's a good idea to be familiar with your your third powers up to 6, I think. 6 to the third is 216. 4 to the third is 64. Okay, let's talk about number 6. All right, again, the first thing we're going to do here is move this whole thing to the bottom of the fraction, x to the third minus 1, where it becomes the positive second power. That's the key. Now all we got to do is expand this thing. You know, classic math mistake, x to the third power minus 1. This is equal to, let's draw a little thought bubble here. This is equal to x to the third minus 1 times x to the third minus 1 when you multiply it by itself. Very common math mistake. I've made a lot of TikToks about this joke. that you can't just distribute that 2 the way you want to. You have to multiply it all the way out. It's 1 over x to the 6th power minus 2x to the 3rd plus 1. And all I'm doing there is just expanding it out in my head. X to the 3rd times x to the 3rd. I don't know if you're familiar with the magic box method that I like to use here. But really, it just helps you organize and make sure you got everything that you need there. That's where the minus 2x to the 3rd came from. There's 2 of those. Let's go to number 7. Remember, the magic of this video is that you can pause it at any time if you need to see more things. I have a habit in homework tutorial videos, just flip to the next question as soon as I'm done in the interest of time. So if you need to see it, just click pause and you can see it. Okay, here we go with fractions now. What we need to remember is this is a square root. This is equal to the square root of 121 to the x to the 8th. Although I don't really like root notation. I think the fraction exponent is much more expressive. I like to think about this as 121 to the 1/2 power times x to the 8th to the 1/2 power. And here it's really easy to see that 8 times 1/2 is 4. So it's going to be x to the 4th power. And the square root of 121 is 11. So this is 11x to the 4th. That. Number 8. Again, here, see we have the number on top, number on bottom, and it's negative. Let's deal with the negative first. I feel like it's a good idea to get that negative out of there. Let's put 8x squared on the bottom. We'll raise it to the positive 4/3 power, like this. So, how to handle this? Well, I'm looking at the 3rd power first. Actually, first thing I want to do is split it up. I want to deal with the number. I want to deal with 8 to the 4/3 power on its own. I'm going to multiply that times x squared to the 4/3 power. Because when it comes to the squared and the 4/3, you can just multiply those together. That's going to be 8 over 3. 8/3, x to the 8/3 power. I don't know what x to the 8/3 power is, but that's what it is. That's what matters. When it comes to the 8, though, these are common exercises in Algebra 2 textbooks. What we're going to do is, well, I'm just going to go ahead and stick 8x to the 8/3 power over here to the side. We're going to split it up. I'm going to think about this as 8 to the 1/3 power to the 4th power. I didn't need that much room. I don't know why I gave myself that much room. The reason why is because I know from doing math that 8 to the 1/3 power is 2. That's the cube root of 8. And 2 times 2 times 2 is 8. So this is equal to 1 over 2 to the 4th power, x to the 8/3 power. Again, all I did there is 8 to the 1/3 is 2. This is how I avoid using a calculator on this problem, because I don't know what 8 to the 4th power is. It's astronomical. But I do know that 2 to the 4th power is 2, 4, 8, 16. So this is going to end up being 1 over 16x to the 8/3. Again, that problem could have been done a lot faster, probably, but hey, we're here to explain everything, not to just get the answer. It's not about the answer. Is the thing I'm fond of saying in my classes. It's about how you get there. It's about understanding it. So the answer is less important to me. You'll find I give you the answers for just about everything. But it's not about the answer. It's about building that bridge, understanding with this start and this end, how does that make sense? That's the key. Again, this problem is going to start with moving everything to the bottom of a fraction. Is a negative 32 in that parenthesis. X to the negative 5th power raised to the positive 3/5 power. It's very similar to the last problem. We're going to split up the negative 32 and the x to the negative 5th power. It's always a good idea to work vertically whenever you can also. It's a common thing we'll say. I try to give you enough room on your stuff that you can do step by step by step by step vertically as much as possible without needing to go to the side, which is a bad habit that I have. Let's see. Talking about negative 32, I do know that 32 is a perfect fifth. It is 2 to the 5th power. If you don't know that fact, this problem is a lot more difficult. But so I'm going to think about this as negative 32 to the 1/5 power, then raised to the 3rd power. Meanwhile, the x's, the 5s, are just going to cancel out. This is x to the negative 3rd power. So what's going to happen in the next step? I'm going to do two things at once. First of all, x to the negative 3rd is going to jump back up to the top because it's negative 3. So this is x to the 3rd on top. Now, on the bottom, negative 32 to the 1/5 power is negative 2 because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is negative 5. Sorry, it's negative 32. So this is negative 2 to the 3rd power. And so my final answer is x to the 3rd over negative 8. Like that. Does the answer key I'm looking at agree with me? It does. All right, let's do one more. These are going to start getting kind of stupid and complicated, but not too terrible, honestly. Okay, all we have here is more stuff. I think what's important in this problem, let's go ahead and take all the non-exponent related stuff and gather it together over on the left. Let's do 1/4 times 32x. That's just 8x. We can deal with that later. Meanwhile, we got a bigger fish to fry. We have, I'm going to go ahead and combine the first two steps of the last couple problems. We have 16 to the 3/4 power, positive 3/4 because it's on the bottom of a fraction now, times x squared to the 3/4 power. So, combining these ideas together, let's go ahead and move 8x, which is what 1/4 of 32x is. Let's move that to the top of the fraction. We'll stick that up there, 8x. On the bottom, let's think about 16 to the 1/4 power separately, and then raise that to the third power. I happen to know that 16 to the 1/4 power is 2, because 2 times 2 times 2 times 2 is 16. We've talked about that already in this video. And if we multiply 2 and 3/4, that's 6/4, which I will write down in this problem. I know that 6/4 is 3 over 2, so we'll reduce that in the next step. So we have 8x on top. We have 2 to the third power, because 16 to the 1/4 power is 2. And we can reduce 6/4 to 3/2. And there is our final answer. Actually, we can keep going a little bit. One more step, because that's 8x to the 3/2 power. Actually, we can keep going a couple more steps. The 8's actually cancel out here. 8 over 8 is gone. And so what we have is we have x to the first power over x to the 3/2 power. And now we can actually use the division rule that we mentioned back at the beginning of this video. We can subtract these things. 1 minus 3/2 is equal to -1/2. So this would be x to the -1/2 power, or 1 over x to the 1/2 power. Or if you like, 1 over the square root of x. Could be another way to write that. There's 3 different ways to write the final answer, in case you needed more. It's a pretty cool problem when it's all done. Number 11, I'm trying to respect the space of each problem, though, too. I'm going to kind of just make a little border wall there. Okay, now I think what's best for this problem, let's go ahead and take that x squared minus 1 to the -1/2 power. Let's move that to the bottom of the fraction. I'm going to do that right away. This is 1 over. Let's take x squared minus 1 to the positive 1/2 and multiply it times x squared plus 1 to the positive 1/2. I'm not sure that these can combine in any meaningful way. I mean, I guess they're both being raised to the 1/2 power, so we could kind of factor that out. But factoring is the wrong word to use here. But I don't know what word to use. Let's go ahead and use a square bracket because we have a different parentheses inside of it. It'll be x squared minus 1 times x squared plus 1. And that is a square bracket. Let's raise it all to the 1/2 power. I think that's about as far as you can go in this. I don't think anything else can happen. A really common, I'm going to take actually a minute to talk about a really common math mistake you'll see all sorts, high school and college students, myself included, really common. A times b to the, or a plus b to the x power is not equal to a to the x plus b to the x. If you don't believe me, literally pick any 3 numbers for a and b and x, and it will almost never work. It doesn't happen that way. What you're doing is you're trying to combine the idea of adding with the idea of exponentiation, the same way that we combine adding and multiplication with the distributive property. I mean, the distributive property works because we're jumping from one level to the next, ax plus bx. This is true. This works. But this one, no, does not work. Very common error. Number 12, one more of these. Let's go ahead and move everything to the bottom of the fraction first. We have x to the -2 plus 2 to the -2. And they're all on the bottom of the fraction. Let's see. Well, we can go one more layer deep. We love fractions within fractions. So x to the -2 power is 1 over x squared. And 2 to the -2 power is 1 over 4. And 4 is 2 squared. That's 1 over 2 to the positive 2nd power. Yeah. Well, we could stop here. Technically, we've done what they asked us to do, but we can keep simplifying if we want to. The way that we're going to simplify this is we're going to get a common denominator with both those. And the way we're going to do that is we're going to look at the denominators, x squared and 4, and we're going to determine what the least common multiple of those two things is. And that's easy to do. It's 4x squared. So we're going to multiply this entire expression by 4x squared over 4x squared. And the reason why we're going to do that is it actually will give us a common denominator on the bottom of the fraction. Or it will actually clear out the fractions, because 4 and x squared both divide by 4 and x squared. Let me show you. On the top of the fraction, the 4x squared from the top is just going to park it right up there. But on the bottom, we're going to have 4x squared over x squared plus 4x squared over 4. Because we are distributing. We're multiplying the bottom by 4x squared. And those of you guys in the know, notice that x squareds will cancel out and the 4's will cancel out. Which means that I think the simplest expression here is 4x squared over 4 plus x squared. That is a good, simple answer. I like it. Hey, that one was pretty straightforward. You guys are going to do great in this class. It's going to be so good. What a good experience it's going to be for you. Very excited to meet you guys in the fall. I'm hoping that you're following along, doing a little bit of math work, doing a little bit of math thinking, keeping your skills fresh. The thing that you'll notice, a lot of the comments I got from seniors the last 3 or 4 years is the pace. This class is a college class. It's technically a college class, and it moves at a college class pace. So be prepared for that. There's not a lot of time to go back and review things over and over again, so you have to be on your game while we're together. And that's why we're doing this summer packet, to keep you fresh. So you are great. You're fantastic. You're wonderful human beings. So smart, capable. You can do it. You got it. So I'll see you in the next video.